Hello YouTube, this is Jay Coder back with another stream, and today we're going to be going over a coding challenge in Kotlin. And if you like this kind of stuff, please subscribe to the channel, comment, like this video, and without further ado, let's get started here. And what I have for you today is the coding challenge on Leet Code here is called Unique Binary Search Trees. And we're going to be solving this in Kotlin today. So it says, given an integer n, return the number of structurally unique BSTs, that's binary search trees, which has exactly n nodes of unique values from 1 to n. And then they have an example image here. And so input n equal 3, output 5, and example 2, input equal 1 and output equal 1. So 1, 2, 3, 4, 5 is the unique arrangements of 3 nodes. But anyway, all right, let's go ahead and solve this in Kotlin. And so basically, what we need is to start out with what we need is to initialize an array to store the number of unique BSTs for each count of nodes. The array size is n plus 1 because we want to include the case with n nodes. So what that looks like is I'm going to go val and name it that, and that's going to be equal to int array, and so that's going to be n plus 1. Okay, and so with this, so there's going to be the base cases dp of index 0 equals 1 because there is exactly one BST with 0 nodes, which is an empty tree. And there's dp sub index of 1, and that would be 1 because there is exactly one BST with 1 node, which is the root itself. And so I'm going to go ahead and set those equal to 1. So there's a dp of 0 equals 1, dp of 1 equal 1. Okay, and so basically we need to fill the dp array using a formula from the number of unique BSTs. And basically, the formula looks like this. Let me go ahead and make a comment here. And then BC of, I'm sorry, C of n equal C of 0, and then times C of n minus 1, and then that's going to be plus C of 1 times c of n minus 2, and then this would be plus, and then that would be plus keep repeating. So this means basically to repeat what we had there. Well, actually, this would be plus c minus 1 n of minus 1, or n minus 1, times c of 0, and so yeah, so this would be c of 0, c of 0 times c of n minus 1 plus c of 1 times c of n minus 2 plus, and so on and so on, c of n minus 1 times c of 0. So basically, this formula represents the sum. This formula represents the sum of BSTs for each possible root. And so I'm going to make a for loop for each number of nodes. I'm going to iterate through all possible roots. So in Kotlin, what I can do for that is make a for loop here. And inside the for loop will be nodes n 2 through n, and then also the number of unique BSTs with root, as the root is the product of the minus the number of unique BSTs in the left subtree, which has root of 1, root minus 1 nodes, minus the number of unique BSTs in the right subtree, which has nodes minus root nodes. And so basically we need a second for loop here. So we're going to do for, and this one's going to be of the root n 1 through n, and then inside here we are going to go ahead and do this dp nodes plus equal this will be like that, plus equal dp root minus 1, And that's going to be times dp, and that's going to be dp nodes minus root. Okay. And then after that, we return the number of unique BSTs that can be formed within nodes. So basically, after this for loop, return we return dp of n. Okay. So let's see. So basically, we get the value n, and then we make our val dp, which is int array, and then the dp sub 0 is 1, dp sub 1 is 1, and so we have a for loop here based off this formula, and so that's going to be the for nodes in 2 through n, and this is going to be the for root n 1 through n, and then inside this for loop we're going to have the dp nodes plus equal dp root minus 1 times dp nodes minus root. Okay, all right, let me go ahead and check to see if this is working. Okay, runtime error. Exception in thread main. The index is out of bounds. Okay. So turn. Okay, do I have this correctly? So it would be dp dp nodes plus equal dp root minus 1 times dp nodes minus root. Okay, and that would be within root n 1 dot dot n, and this would be nodes n dot dot 2 dot dot n, and of course we have that, and then val dp equals the int an array and plus 1. Alright, so we have that. Then we have the turn in. Let me just see something here. So switch Okay. PM notes. Turn. Then run. Exception. Out the bounds. Huh. How is it doing? Out the bounds. And okay. All right. I had one little uh thing off, probably a bracket, but anyway, this is how you solve it. It's so you have this val here of an int array, with an n plus one, and then dp sub 0 equals 1, dp sub 1 equals 1, and then you have a for loop here with nodes n 2 dot through n, and root in 1 through nodes, and then you have this dp nodes plus equals dp root minus 1 times dp nodes minus root. All right. Well, yep. So there's the solution, um, there. And yeah, so that's what I wanted to show you guys today. And if you like this kind of content, please subscribe, like the video, comment. And as always, I like to say, stay coding. And until next time, peace.